Hello, everybody. Welcome to our session. If you're still trickling in, please come find a seat. You're more than welcome. And there are some spaces available, which is nice. So hello, everybody. Welcome. And we're going to spend the next 40 minutes or so talking about what's new in Compose Multiplatform. And we're going to do that in the form of a live tour. I don't want to spend too much time on introductions, but briefly, hi, my name is Sebastian. I'm one of the developer advocates for Kotlin and Compose Multiplatform at JetBrains.
And I'm Márton, also a developer advocate at JetBrains for Kotlin and Compose Multiplatform.
Yeah, so at least that part's easy to remember. The names are still different, even though the jobs are pretty similar. Okay, so we are going to pose a very simple question, which is, what if you, as experienced Android developers, could just do iOS development as well? And as it turns out, with some of the changes that have been happening recently, there's a good chance that you might already be able to do that. Isn't that right?
Yeah, it is. And of course, one of the things that happened recently in this space is that Google, at this year's I/O, has officially started supporting Kotlin Multiplatform for sharing business logic across different devices. So we're seeing more and more of the Android ecosystem, not just third-party libraries, but also the first-party Android stuff, Jetpack stuff, coming over to Multiplatform.
Right, so we figured the best way to see what's actually already possible today is not just have a bunch of slides, but actually build something. So we're going to spend the rest of the session pretty much just in the tooling, and we'll build a small expense tracker. So a small app that runs on Android, on iOS, and even on desktop that just allows you to add a couple of expenses, see how much was spent in total, and so on. And we want to do this kind of properly, so we want to look into having a fully shared UI built with Compose, because that's something you might already know. We want to make sure that the architecture properly separates the logic from the UI. So here we're talking about subjects like view models. We want to make sure that between the different screens, for example, for adding and for the overview, we have proper navigation. We also want to touch a little bit about how you can use resources in Kotlin and Compose multi-platform applications. I'll prepare a little bit about localization. An expense tracker doesn't make that much sense if you don't have some way of actually storing things on disk, so we'll also do a little bit of relational stuff there. And of course, we'll also see how we can kind of decouple our architecture with dependency injection.
And again, the UI of that is going to be powered by Compose Multiplatform, which, as you probably heard in the keynote this morning as well, is built by JetBrains, and it expands the Jetpack Compose UI toolkit that Google built for Android so that you can use it elsewhere as well. More specifically, we have these supported platforms. So on Android, this is of course stable because we are reusing Jetpack Compose as is. On desktop, it has been stable for a while. If you're using JetBrains Toolbox, for example, then that's actually a Compose desktop application. And as you can see, we are in beta on iOS and alpha on the web. And of course, those last two platforms were also moving towards stability over time.
Right. So with that, we can pretty much already dive into the tooling, but just in case you're wondering why there's two laptops up front here, that's because we are using our fleet-based tooling, which has collaboration built in. So what you'll be seeing throughout the entire presentation is my screen, but Márton also has the same session open on his laptop, and he'll be able to also zoom around and has his own cursor, can run interactions and actions, all these kind of things. You'll see that as we dive in. So let's get started with actually building something. Let me find my window. It's a lot of swiping, but it's all happening on a second screen. There we are. Great. So generally what I would like to do is I would like to start building some UI components, like this one, but typically for me it's a lot easier if I first have an idea of what it is that I'm actually trying to render. So Márton, why don't you give us a bit of an overview of kind of what kind of data we're working with? I'm just going to start following you here.
Excellent. So we'll have a couple small data classes that we'll use all throughout this demo. So we'll go through them real quick, just so you have an idea of what the data we're working with is. So we'll We'll work with expenses, which have an ID. They have an ID that refers to the person who paid for it. They contain the amount and the description of the expense. Then we have a different class for the people themselves, just an ID and a name. And because we'll need to display these pieces of data together in a couple places, we also have this combined expense with person data class, which just contains both of the entities together.
Right. And that's pretty much it. So from a structure perspective, you can see here that a lot of the work that we'll be doing is part of the common main source directory. So this is all platform-independent code that we're writing. OK, I have a bit of an idea now, so I'm just going to move over to my components here, and I'm going to start by building out one of these like avatar and name combined things. I can preview this either on, for example, desktop or Android. I can just start the desktop preview. Again, these previews are common, so you can do that without having to write any platform-specific code. The basic version of this only shows us a colored circle and the actual name, but we can kind of just command-click ourselves through here, and we'll quickly see that the avatar that we have over here is only drawing a box. It doesn't really draw any images yet. So let's maybe fix that. We can just go in here. We would need some sort of mapping of like people to avatars. We already prepared something for that, but essentially in here, I'll just pass the person, and if I can find an avatar for them, then we can just use the regular image component that you're already used to, and as a bitmap, I'll just pass in the image resource, which is this drawable resource that we get back here. So a couple of other things that we should typically fill in. For example, the content description here, we can just pass in the person's name since it's just their avatar. We can make sure that as a modifier, this image actually fills the entire size. And as we do that and give this 2 seconds to re-render, we should already be able to see Blake with his avatar. What I typically like to do, because you never know what your input formats might be, is make sure that I set the content scale to something like contentscale.crop. This is always very unintuitively named for me, but if you click into it, you'll actually see that this makes sure that it essentially fills the container and just crops off something around the corners so that you always have a nice image. Great. This is already a pretty good start here, I would say.
Yeah, and as we're doing this, just a reminder, like these are, again, just the same Compose APIs that you already are familiar with from Android, but this time we are writing this in shared code, so we can run it on iOS, desktop, and so on.
Yeah, so we can also take a brief look into what this people to avatars mapping looks like, so that we have a bit of an idea. Again, it's pretty simple. It's just a regular collection. It's a map. You can see here that instead of the typical like R object or R class in Compose Multiplatform, we're using this res object, but you still get type-safe accessors. These will link you into the Compose resources, which have something that is very analog to what you would be expecting. So if I can also command-click onto any of these, and we'll actually see that we have a couple of like gorgeous stock models who are just kind of like chilling in here. Yeah, very nice. I think that was a good warm-up, right?
Yeah, so we have one more component to build before we can keep moving.
Yeah, so let's take a look and just continue with our second component. That's pretty much the other big part that we need, which is this expense item. So I'm just going to do a quick preview of that one to see where we are at. And of course, this is
We're nowhere.
Yeah, it's just an empty row. We still have a little bit of work in front of us. But we can do that quite quickly, right? Because we already know that we have an avatar. The person, in this case, is just going to be
called paid by.
Paid by, exactly. And then as a, we can just kind of continue a little bit. We know that this is a column, right? Because we have a couple of things above and below each other. We want to pass in the expenses description. Which, we could probably adjust some font sizes or that, but we'll just continue here a little bit. And then we have something which is like, you could say something like paid by, and then you just take the person's name again. But of course, as we said beforehand, we want to work a little bit with localization as well. So instead of this, we can use a string resource. So I could just type in here string resource, and then once again, I use the same accessors. In this case, it's res.string. We already prepared the paid by version. And if we actually let this re-render for a second here, you can see that there's still a placeholder. I can command click into this, and you can just see, once again, we prepared some values here, and the paid by just has this placeholder. I see Márton is already getting a little bit antsy, so you already added some changes here. Let me just see if that already looks good. I mean, you got pretty far. I feel like we probably could maybe fix the vertical alignment a little bit.
Sure.
Maybe put some center vertically on this one. And I think that looks pretty much exactly like what we want to have. Great. We have a bunch of components, which means we can probably start building screens out of that, or the logic for screens at the very least?
Yeah, and ideally, we would have this code nicely organized somehow, right? We don't want to put all of our logic and data handling right into the Compose UI code itself. So where might we extract this to?
Well, we have a bunch of different ways of actually doing this. The community has built a bunch of things like KMP Observable View Model. Voyager is kind of a combination between like a screen model and navigation library. Orbit MVI, if you're more of a model view intent fan, that is something that you could use. But in this case, the architecture looks a little bit different. We do want to shout them out, though, because they won a grant of the Kotlin Foundation. And there's also something like Molecule, which brings the composable APIs, or the kind of composable paradigm, into your logic layer as well. Today, we're going to use Jetpack View Model, the one that you already know, because this one was also made available on Multiplatform. So hopefully, there's not that many surprises here, and you'll just be able to follow pretty directly as we go. So I'm just going to hop on over back here to Márton.
Yeah, so in the meantime, I've created a new file for this view model. It's called home view model, and it extends, we're going to say this many times today, just the same view model class that you already know from Android, but that's now a multi-platform compatible class that you can use. Now, in this view model, we would like to have all of the data to power our list screen, which we've shown you earlier in the screenshots. So we'll create a stateflow here, which is going to be called expenses, and this will have a list of expenses with people. And for the time being, we don't have any storage for this, so we'll just use some demo data that, again, we have prepared. We'll swap this out later. So we have some demo expenses with people, and to put that into a stateflow, I can just create a mutable stateflow that has that by default, import stateflow and import mutable stateflow, and I think that's all we need for a view model for now. So with that, we can hop over to the home screen file, which we already prepared with just a bit of Compose scaffolding, and actually start using this view model. So first of all, we want to take one of these view models as a parameter so that we can work with it. So I'll take a home view model here as a parameter, and we can use, again, the usual APIs for this. So we can call the view model function and tell it how to create a new home view model when one is needed. In this case, just calling the constructor. Of course, we'll clean this up with a quick import like that. And once we have a view model in our hand, we can start observing state from it. So we can take our expenses, which we can grab from the view model. This is a state flow, as we've just seen. So to transfer this into Compose, we're going to collect it as state. That will give us nice observable Compose state. And not only do we have collect as state, we also have the variant with lifecycle available now. So that whenever the lifecycle of the application changes, it goes into the background and so on. We can shut down any expensive running processes that are generating data for our flows. So we have our expenses. You can see that we have a lazy column prepared here. So I just need to populate it with items now. I can take my list of expenses. And for each of those, we can use one of the expense item components that we've written previously. Now, this takes an expense and a person as a parameter, both of which we're receiving here in this combined data class. So I'm just going to take this and destructure it, expense and person, and then take those two parameters and pass them into the item. What else do we need for the screen? We need the total amount of all of the expenses, so we should quickly calculate that. We'll do that based on the list of expenses, of course. We can key this to the expenses so that we rerun it whenever the list itself changes. And then the calculation is simply taking the expenses, summing them up, and for each of the expenses, we want to sum their amounts. Now, I could just concatenate this into a string, but of course, you've already seen that we're using nice string resources that we have prepared in the project. So I'm going to go to the resources object, string, and look for something called total. Here again, we can import this. I can hop over there, and we can see that that's a string with a placeholder like this. And we need to pass in the actual int that we calculated. And then the last thing is this button on the bottom of the screen, which will eventually navigate us from the list screen to the screen where you can create new expenses. So here again, we have a string resource that's going to be res string something like add expense. There we go. And of course, we want to have a callback that this screen can signal with so that we know when to navigate away from it. So other than this view model, we also want something that we'll call onAddNewRecord. And that's just going to be a very plain function with no parameters. And we'll make sure that we call that whenever the button is clicked. And I think that's a home screen implementation.
Yeah, from this perspective, I think that's fine. We can just kind of hook this up in our app here, so we can just grab the home screen. For onAddNewRecord, we're not going to do anything so far, and the home view model gets automatically generated by that factory. So at this point, we could already start running our application on, well, maybe a connected device or on Android as well. I'm just going to start it on desktop for a second, just so that we kind of have some nice quick visualization. And over here it is, our little expense tracker. Already looks pretty good. I'd argue it's probably good enough to already get our first angel investors, but it's maybe not quite there yet to go all the way to the App Store top 100. So we're still working on that part. We'll also see what this looks like on other platforms, but before we do that, we were doing a whole shebang regarding the localization here, so I just want to show off how that works. Our compose resources, just like the resources you might know, are also parametrizable. You can parametrize them.
You can add qualifiers to them.
Sure, qualifiers. Let's do that one. So I'm German, so the German translation is the only one I can reasonably check. So what I'm just doing here is I'm just copying it over into a values DE, and then I'm just going to use the AI assistant here for speed to just ask it to translate this to German, and then we'll just check whether this looks good. Ausgaben, this all looks pretty good.
That sounds great to me.
That's excellent. Do you speak German?
I do not.
That makes that much better. Okay, so we're just going to run this on my iPhone emulator here, which, as you can maybe see, has wonderful things like Kontakte, Dateien, and even Kurzbefehle, like all those fancy things, and Dienstprogramme, which just means tools. It's the longest word ever, so long that even iOS abbreviates it. But as you can see, as the app starts here on this German iPhone, it automatically picks up the fact that it is, in fact, localized, and we see bezahlt von Alex and Gesamt, and so on. And of course, we can also run the app on Android as well, just so that we get a good idea that we are indeed building a multi-platform application. So we can just pull that one up here as well. This is an English Android device. Yeah, so that also, I hope, looks pretty good. Great. We probably still need to do a little bit of work, especially since, as we said, it's an expense tracker. I can't add new expenses, and these expenses are also just demo data, right?
Yeah.
We got to store them somewhere.
What if we had somewhere to store these? Again, we have a lot of great options here with KMP already as part of our ecosystem. We have had libraries like SQLDelite and Realm around for some time now for structured storage. We have KStore that allows you to write things into files. We have data store and multi-platform settings. So again, a Jetpack and a community library for storing preferences across various platforms. Once again, multi-platform settings is one of the very cool libraries that got a grant from the foundation recently to develop it even further. And of course, we have Room now, as of this year, which Google has migrated to support multi-platform. So that's what we're going to show you today. Again, going with the theme of of tools that you already know from Android development, which just work across platforms now. So to set up Room, we're going to write some annotations. We have our data classes that we looked at earlier. I'll try to generate this with AI Assistant as well. You are not going to see the prompt I'm typing in, but I'll read it, and you'll have to trust me about it. So I'll tell AI Assistant to add Room annotations and include a foreign key, because we want a connection between the two tables. And let's see what that does. So we have an entity class. We're going to generate its IDs. That sounds fine. Of course, we can customize this, which I like doing so that our queries look nicer. So we'll call our person class just people. And then for the expense as well, it looks like it didn't add a table name, but we can call this expenses so that it works nicely. And I think I broke something. Let's roll that back and do it again. So I'm just going to git revert the file. Let me grab an expense real quick. OK, let's run that again. Add room annotations, include foreign key. And I feel like I must have touched it while it was still populating things, because now it actually spit out everything. Good. So again, I do want to name these tables nicely, so we'll just do that one more time. People, auto-generated ID is perfect. And then we have the other class. We can take a look at this foreign key that's set up to connect the two tables. So the ID column of the expense class has to the ID column of the person class has to connect to the paid by person ID in the expense class, which is all correct. And again, I just need to add the table name here, which is going to be expenses. And then we have this combined data class with an expense and a person. So the way that that's going to work is that we're going to query for the expenses, so we can make that an embedded thing within this class. And then for Room to automatically pull the associated person with it, we can add a relation for this one, which again just connects these things through the IDs and the foreign key. And I just need to import that. And I think with that, we are done with that setup. So we can keep moving and start setting up a database. Can we look at some of the documentation for how one might do this?
Oh, absolutely.
While I
100%. So there's a couple of one of the very nice things is that learning all of this stuff has become a lot easier recently, because you can just literally head over to the Android developer documentation, and there's an entire section on Kotlin Multiplatform, which includes things like data store, but also Room, which includes a lot of the snippets that you would require to kind of set up originally, right? It tells you how you instantiate the database for the first time, and it also contains the snippets that you need for platform-specific integrations. Because at least with databases, you most likely want to put them in different places on the file system, right? On the JVM, you probably want to put it in some kind of directory if you're putting it on the desktop. On like iOS, for example, you're using the iOS-specific APIs through Kotlin Multiplatform. And then on Android, you're just using the application context to figure out where you want to put things. This code might look intimidating at first, but the good part is you can pretty much just copy-paste it, and you can just kind of move from there, which is nice. So, Márton, what have you been doing?
In the meantime, I got started on writing the database classes. Again, a lot of annotations, but the same pattern as usual with Room. So the thing that we'll use to actually access our data is going to be a DAO. So we have an interface defined for this here, which Room will generate the implementation for. It's annotated with @DAO. And we have our first transaction that we'll use, which just gets all of our people and the expenses with them. We are marking with this with a transaction because we're using that embedded combined class. So Room is actually performing multiple different queries and combining them. So the best practice is to do a transaction there. What I didn't write yet is the KMP specific part, because that's a bit more interesting. So we have the actual database class here, which needs to extend Room database and which will return the DAO to us. And we do still have to annotate this with database as on Android. And then we have to list our entities. So that's going to be an array of the expenses and the person class so that we know what our tables are. And then we need to specify a version, which, because we've done this a couple of times now, let's do like version 42 so that we don't conflict with any existing data. And finally, the KMP specific part, which is a bit different, is that you need this additional room constructor. So as you can see, this can just be an empty object that extends the room database constructor type, parameterized with your specific database. And this is defined as an expect object. So we're writing this in common code, and then a room will actually generate platform-specific implementations for hooking into whatever platform stuff it needs in the background. And just to connect this with the actual database, we can do constructed by and my database constructor class, barring typos. OK. So at this point that we have the first query, I think we should be able to start integrating this on the view model side, where we need to access the data.
I mean, I have everything I need. I can head on over here. I can make sure that my home view model keeps a private reference to the DAO, which is an expense DAO. Maybe I'll give that a little bit of a better name here. So we'll just make sure that this is actually called expense DAO. And then we can rip out this mutable state flow that just has some demo data, and instead we'll use the expense DAO directly. So this one here, once again, Márton wrote the query get all with people. So I'm just going to use that one. The types don't work out quite yet because get all with people is a cold flow. And of course, if with a state flow, we're looking at a hot flow. But the conversion isn't anything special. It's the same way that you would do it in any other scenario. So we use state in, and because we're in a view model, we can just pull our view model scope. That even works in multi-platform. We don't really have to do anything here. We can still fill in the other parts that we need for state in. So we'll make sure that our sharing is started, for example, just make sure I get the nice overview here. We get while subscribed, maybe with like a timeout of like 5 seconds. And as long as we haven't really gotten anything back from the DAO, we'll just provide an empty list, which is kind of cut off here. Let me just put these parameters on separate lines. Where's my autocomplete? There it is. Great. So yeah, here we're just doing that little bit. OK, great. Márton, have you been busy in the meantime?
Yes. So I expanded a bit on our setup on the room side. So we're going to need a couple more queries for the entire app to function. So I wrote a couple more queries. We're not going to go through these because just room queries again. What we do have here is a helper function that will help us. Once we have a platform-specific room database builder from somewhere, we're going to be able to call this common configuration function on it, which sets up things like the migration configuration, sets up the SQLite driver to use, and, for example, sets up the coroutine context so that we use the IO dispatcher for these queries. Now, we do have one final challenge here in the room setup, which is to get one of these platform-specific builders. And for this, we have stolen some of that code from the documentation that we already looked at earlier, so we can review that real quick. So on the Android side, for example, we have this function, which creates the database builder for us. Here, we're using Android-specific APIs because we're in the Android main source set. We can use the context, we can fetch the appropriate directory, and specify the path based on that. Then on the desktop side, we have all of the JVM APIs available to us. So we're using just the file class and system properties to get a path there. And then on iOS, again, in iOS main, we have access to the platform-specific APIs, just directly calling into these native APIs. So we can use something like NS home directory and create the required path that way.
We still got to figure out how to call all of these functions, though.
Yeah. So ideally, we would want to call these functions that create the database builder and then the common configuration on it on each platform. And we could really use something that lets us create and inject these dependencies. Right.
So obviously, we're going to do a little bit of dependency injection here. And there's a couple of different ways of doing that in the multi-platform scenario. Kotlin inject is one of them that might already have a pretty familiar API. If you've worked with like Dagger or Hilt, There is also codeine, but today we're going to be using coin simply because it's pretty popular. It also already has some very nice integrations for compose multi-platform specifics like view models and so on. Okay, so let's actually see what that looks like in practice.
Yeah, so an easy way to get set up with coin is to create a function that will initialize it for us. Here we have just one dependency that coin needs to know about that has to come externally. So that will be the Rune database builder. And then we need to organize our code into modules using coin's DSL. So we'll create our first module for the data stuff. I'm going to import that function. And then we can use single to specify a singleton. So I'll make the database a singleton. And the database, of course, is created by taking our builder and then calling get Rune database on it, which again is that common config function that we wrote earlier. But at this point, we could only inject the database because that's all that Rune knows about. But it's actually more convenient to inject the DAO. So we'll take another single declaration here, and we'll use the get function to grab the database from the DI graph. And once you have the database, it has that generated expense DAO function that gives us the DAO. Then we need the view models to know about dependency injection. So for another coin module, just to organize our dependencies a bit, we'll create one of those. And coin integrates very nicely with view models on KMP as well. So we can just create a view model declaration here. And instead of a home screen, I meant to use a home view model. And that has an expense database dependency now, or an expense DAO dependency now. And I can just call get using coin, and that will fetch it from the graph for me. And then at the end of this function, we call start coin, and we go modules, and we pass in the data and the view model modules. So that's our DI setup. The final step in configuring this before we get back to the Compose UI is to call into this function on each of the platforms. So when our iOS app, when our Android app, when our desktop app starts, we want to create the database builder, pass it into the DI so that we can get going.
So this is a task that, once again, actually happens in the platform-specific source sets. So the entry point for our Android app, for example, is our onCreate function. In here, we can just call initCoin, and we'll pass in the database builder, right? And in our case, that's just this create database builder function that we wrote specifically for Android, this little one. So this one actually also needs a context. But the good part is, because we're just in Android code, we just have the context because we are in the application. On desktop, it's looking pretty similar. It's just a little easier because here our entry point is just a main function. So we can just call initCoin, and because our implementation of create database builder for desktop already has a file system path built in, we don't really need to make any changes here. The only part that maybe becomes a little bit more interesting is the iOS part. Because here, if we click through and we see that our entry point comes from this Compose UI view controller, which is this main view controller, which I can command click into, and it sends me into the Swift code here. We can see that this compose view is part of the content view, which is part of this iOS app. So this is the actual entry point of the Swift application that then does some multi-platform code. So I could, of course, call some like Kotlin code directly from here and pass in some builder functions, but I think it would be much nicer if I had some sort of like helper functionality, I don't know, coin iOS KT, and then just do initCoin without any parameters. Weird that that already exists. Márton, have you been doing something?
Yeah, so because we want to avoid having to call into Kotlin code to grab this object, taking it back to Swift, and then passing it back to Kotlin again, we just created a very short function. This time, again, this is in the iOS main sources, so that it can use iOS-specific APIs. So it just calls that function, passes it back into initCoin, and then we can call a simpler function from the Swift side, which has no parameters.
Very nice. So we have parameterized everything?
Yeah, so let me rerun the app.
Yeah. I can actually, I'm going to step away here. Márton also has a device chooser on his screen, so he can also just run the application. I don't have to do it. We can still see the pop-ups here of the individual builds, which has failed. Most likely, why?
We broke something.
Hey, that's exciting.
No value passed for parameter.
Oh, look at that. Thank God that we're working in a type-safe language.
Nice. What a prepared demo that is.
Right?
So obviously, we used to create the view model with the original Compose APIs for this, but we now have a DI setup, which would provide a parameter for it that it's currently lacking. So instead of using that view model call, we can use coin view model now, which we just call like this, and that will pull into the DI graph and grab values from there. So let's do that one more time. Let's compile for iOS, for Android, and for desktop, and see how that goes.
Oh, that's looking much better. Look at that. We have...
Other than launching on the wrong screen,
well, you know,
we are doing quite well.
Yeah, we got the desktop version. We got the iOS version, which is still building, so we'll just give that a second, and then that's going to refresh. And we have the Android version as well. Now, what might be a little bit weird here is that, of course, you're still kind of seeing the same data as beforehand, but I thought we were going through a database. So where's this data coming from?
Yeah, so we promise we're not showing you the same hard-coded data again. The way that we populated the database is that I snuck in a small demo initializer here, which is a tiny function that just grabbed the DAO and then dumped all of our demo data into the database so that we don't have to mess around with getting that prepared. But now that we seeded the database once, we're just going to remove that line. And then whenever we run it again, we're not going to keep overwriting things with demo data. But what's really missing is to actually be able to add new data ourselves, right?
Yeah, the button doesn't work.
The button doesn't work.
So in this scenario, what we obviously want to do is we want to have some kind of navigation back and forth, right, between our different screens. And there's, again, a couple of ways to do this. Voyager did this originally already quite a while ago. There's also projects like Pre-Compose, for example, that provide a navigation solution. We're going to show off Compose navigation for you here. Why? Because that's, once again, the exact APIs that you already know. Because pretty much what we at JetBrains just did is we took the official navigation Compose or Compose navigation, and we converted it to multi-platform. So if you're actually coming at this from a non-greenfield perspective, and you need to work with a multi-platform scenario, you don't need to do any kind of migrations. And of course, you also get all the benefits from when this navigation component evolves. For example, we get type-safe navigation, which is of course very nice because it means you don't have like a stringly typed layer somewhere. Okay, cool. So let's build something against that, I'd say.
Yeah. So for this to work, it would be nice to get started with the add screen. So we'll start this from the view model side again before we add the UI on top of it. So we'll create an add view model, and we'll make that use the DAO as well, because it will have to read and write some of the data in our database. And actually, with that signature in place, you can already hook that up on the coin side, if you would. Yeah,
so I can just head on over here to our coin KT file. I'm over here in our view model, and we'll just say we now have a second type of view model, which is the add view model, which also just gets its parameters magically, which we need to import. There we go. Okay. Have you been busy?
Yes, very busy. I think we're running low on time, so we're going to speed this up. So what's the add view model going to do? It has the same kind of setup, again, pulling data from the DAO and then converting that into a state flow. This time that will be the list of people that we can pick from to assign expenses to. Then it has another state flow that it can use to signal from the view model to the UI that we have created a new record so that we can navigate back and close the screen. And it has this create record function, which takes some parameters from the UI, creates a new expense, and just creates a coroutine, calls into the DAO, and creates that new database record. Once again, we're using the same APIs as on Android, so if we just need a coroutine in a view model, we can call view model scope, and that works exactly as you would expect. Now, at this point, we should start working on the screen as well, right? So sure. We'll hop over to a file that I also created in the meantime, which is called add screen. This will be a composable function. And I'll just do the signature here first. Yep. So it will need to be able to signal that we have created something. So we'll create a callback for that. We'll call this onDone. And we also need to work with the view model, which we already have. So that's an add view model. And now we're going to remember the first time around that this should come from coin. So I'll call into coin view model with no parameters. And that will grab it from the DI graph. And we didn't forget to add it to coin, which is excellent. So with this, I think we can go over to the navigation side because we have all of the composable functions that navigation has to call into. And while you hook that up, I'll implement the second screen.
Wonderful. Yeah. So once again, compose navigation. This shouldn't be too tricky for us. We hopefully have a rough idea of how to do this. Generally, we start by providing like a nav controller, right, which is just a remember nav controller, nothing special here. And then we provide a nav host. We'll parameterize this in a second, but we know that the last parameter is going to be some sort of like actual navigation graph, right? So generally, we first pass in the nav controller, which in our case is just the nav controller we just created. We also need to provide a start destination. Because we're using type-safe navigation here, I'm going to use one of the objects that Márton just gave me. So I'm going to specify that it's the home route. Typically, you just put a string in here. And now we'll just specify the two routes. We have one of the routes for the home route, which is our home screen. We'll move that in here. And we can immediately say that when you add a new record, you want to navigate to that second route, which is called the add route. Likewise, Márton's already added it here. If we are on the add route, we want to render the add screen. And when we're done, we want to navigate back. Yeah. So I think this is pretty much where we're at. Let's have a very, very brief look into what that actually looks like from the add screen perspective here.
Let's start building the apps and
running
them. So I'll run iOS, I'll run Android, stop the existing one, and run desktop. So if we go back to the add screen, I have filled that in the meantime. So the screen is looking at the view model to see when a record has been created so that it knows to signal with that on-done callback. We have a couple pieces of state here, which are just storing the user's inputs. We are observing the list of people from the database so that we know who to display. And then we have, again, a lot of standard compose code. We have a lazy row, which will show all of our people that you can pick from. And then we have some text fields to enter data with. The most interesting bit of this is probably that we're making sure that whenever you're entering the amount, then we are filtering the input so that you only enter digits. And we have things like the keyboard options configured. So whenever you use the software keyboard, then the appropriate version of that shows up. That's not a full QWERTY keyboard, but actually just shows the digits. And then we have a button at the bottom of the screen, which calls into the view model to create the new record.
Yeah, all of these bits you already pretty much know. Again, the beautiful thing is that we're not really showing you anything new here. So now I can head in over here. I can hit the button. It actually transitions me over, and I can add a fee of $500, which is the droidcon talk too long fee, which is, or maybe, you know, like maybe we'll have to expense your lunch through this app. Not sure how we'll do it, but yeah. And of course, the interesting bit here is that if I turn on the software keyboard across different platforms, this also gets picked up correctly on iOS as well. So in conclusion, we've built an app that works across 3 different platforms and that behaves pretty much exactly as you would expect everywhere, which is nice.
Yeah, and we used a bunch of the existing ecosystem, a bunch of the libraries that are available for KMP, but of course there's so much more. As you can see, the number of libraries here is rapidly growing. We have thousands of libraries at this point that you're going to be able to pick up for all of the kinds of common tasks that you need to perform while doing app development.
Right. Yeah, if you want to get started, you can head over to jb.gg/compose, which also brings you within 1 or 2 clicks to all of our getting started documentation for pretty much everything you also saw today. We also have a lovely community on the very open Kotlin Lang Slack, over 50,000 members in general, with channels for Compose, Multiplatform, for iOS specific, and so on. We did rush kind of through this, and a couple of parts we didn't dive in so much. We certainly spared you all the Gradle configuration that happened in the background. So if you want to see that, head on over to Márton's repository, where you can see the exact code that we wrote here today. And yeah, if you want to dig deeper into this, we hope that it contains a couple of learnings for all of you. Yeah. Apart from that, if you have any questions, at 3:10, we are going to be in the Chromecast room, which is downstairs. We'll have a little bit of a roundtable, and you can talk to us about anything Kotlin, whether that's Compose Multiplatform, Kotlin on JVM.
Language features.
Anything, exactly. So thank you so much, and we hope that you will try this and enjoy lunch and try Compose Multiplatform.
Thank you.